thank you for, well, coming here despite this late hour. And okay, now I am working for, okay, let's see, it's this. Okay, for the company Terra Quantum, which is doing a variety of Terra Quantum technologies, and I'm Chief Technology Officer in the US. And the spectrum of what we're doing actually is quite wide. And I'll try to, okay, to give you like impression of what we're doing. So we started as a startup, and we exist about, Misha, how many years? 3 years, okay. Well, we were a usual startup with a capital of like 3 millions. Now we raised to 90, and the amount of people working for our company increased accordingly. And what we're doing, one of our directions is quantum computing and security, and then we have, as we call it conditionally, 3 pillars. One is quantum algorithms. It's here. And we developed new hybrid quantum algorithms manifesting enhanced speed and combining most advanced quantum and classical methods of computations, and capable of solving the problems which were considered to be most hard, like problems of optimization for finance and science. And we have like, okay, another our representative, Michael Perlstein here, who can tell you much more detail about this pillar. Then we have quantum computing. We are utilizing, and we work together with QMware, and we have hybrid quantum cloud. And basically what we're doing, we develop hybrid structures. And we also develop our own quantum processing units with the unique, again, our development hybrid architectures. And then another pillar of this computation and security is quantum communications, new protocols and encryption libraries, which actually, and with this, about this I'll tell maybe in a little bit more detail. We promise complete 100% secure storage and communication of the data over large distances, absolutely unavailable to anybody else. Okay, so this is like one of the examples. So we have optimization problems, and this shows how well we're, let's say, proceeding with this. We have machine learning. Actually, one of our directions is machine learning and artificial intelligence. And again, this is, okay, shows advance of our technologies which we use. And we have, and one of the things we're doing, we are capable of solving linear algebra and nonlinear differential equations in the volume which was absolutely unavailable before. And again, this comparison shows how well we are doing. As I said, we interact with this QMware hybrid quantum cloud, and we also develop hardware. So one of these hardwares is ferroelectric-based field effect transistors. This was actually the main content of my talk, so I just mention it. And another thing which we're doing is we develop new superconducting qubits, which we believe will be able to work at elevated temperature. So quantum computers which we have now work at very low temperatures, so it's great, but it will be even better if we will be able to work, let's say, at 10 Kelvin instead of 10 millikelvin. And this, okay, and this is one of our directions. And okay, this is how we work with the client. Actually, we have clients, and we offer to them access to everything what we're doing. It's just the list of what we're doing and to what we offer them an access. And what the thing at which I would like to, let's say, stop with a little bit more detail, this is, okay, quantum encryption and this secure quantum communication. Well, if you just open any press release or any advertisement of these quantum companies, you'll find out immediate communication that our glamour future is quantum computing, when we'll have quantum computers at our disposal at every household kitchen. And this is absolutely great, but then there is a negative side of this glamour future, which means that these quantum computers will be able to break down any, let's say, encryption, any ciphering, and they're so powerful that there is no protection against them. And what we're saying, that we develop the 100% protection against this quantum, okay, hypothetical quantum computer break-in. And not enough. What we can do, we can provide the safe communication over global distances, which is again not available to anybody, I believe. Well, beautiful picture. Well, we cannot win 3 times around the globe, but we can do it 1 time. Well, it's just artistic. This is artistic enhancement, but just to be more convincing. And basically, it was mentioned pretty well that it's good to have fundamental physics, connection of fundamental physics and applications. And this is exactly this is exactly how our Terra Quantum started. One of the most fundamental problems, let's say, in life and in physics is the origin of irreversibility. Because we know that all the laws of physics and all the laws of nature are invariant with respect to change of the sign of the time. But if we can change the sign of the time and nothing happens to these fundamental laws, then the question immediately appears why we are aging, but nobody could see, well, except for science fiction movies, of course, why we only age, but nobody saw us getting younger. Small contradiction. The key how to solve this problem was, the guess was done by 2 great people, Landau and von Neumann, independently about 100 years ago. And the solution, comes from indeed quantum mechanics. And we, wrote a paper which was pure abstract paper explaining where irreversibility appears in our life. Since it was beautiful theoretical paper, always, of course, it's a question whether we can, test our beautiful theories in experiment, and it was done. And how can it be done? Since we knew the algorithm by which universe can only age, if we know this algorithm, then we have to be able to turn it around and make things younger. And this actually was done. This was, we found a system, controlled quantum system, which we could evolve back in time, and we did it. This, this was covered in New York Times and other, let's say, media. And this was exactly 2 fundamental works from which we derived our new approach to cryptography. And it was completely change of the paradigm of cryptography and the protection, because all the existing methods are based, let's say, on the mathematical approach. We don't have enough time, so I'll be just crude. So to invent the more and more sophisticated way of ciphering or encryption. Well, then people invent how to break it, to break the code, then new thing is invented. And our approach was completely different. We took approach based on not on mathematical tricks, but on physics, and based on the fact that we can completely control the line of communications, this fiber optics, on a long distances. And since we can control it, we can immediately find the moment when we have the interference. Coming back. And this is like, this is the scheme of how our safe communication does work. So, you know this. We have Alice who is sending the message. We have Bob who is, suppose who is the receiver. And we have eavesdroppers, who is Eve, just by this accepted notation. And this is basically our line. So without going into much of the detail, we immediately, what we can do, we developed new kind of quantum key distributions and new protocols. And basically what we do, since when we send coherent quantum state along the line, we immediately know if someone is trying to interfere, because, this is the foundation of quantum mechanics. If we measure the state, then we change the quantum state. So if someone interferes, we immediately know about that. And then we can adapt our protocol, just decreasing the number of the photons in the coherent state which we send along the line. And then what happens, if the intercepted signal, is small, we can decrease it to the degree when it will be only a couple of photons, intercepted by Eve. And if it's only a couple of photons, to be simple, then quantum fluctuations become enormous and they completely bury the information which was transmitted by these photons. So this is our approach. And this is just quantization of our approach. If the intercepted signal is small, then we have a very high speed of transmitting the signal, 1 gigabit per second. If it will be 0.1% of intercepted, then the rate of the transmission is a little bit less, but still quite impressive. And we can go over these 40,000 kilometers being absolutely secure. So this is one of the examples, probably one of the most striking, and therefore this is what we're doing in all the directions. Thank you very much.